Today we will discuss types of control charts. So control charts are most commonly used methods of statistical process control which monitors the stability of a process. It is a powerful graphical tool of detecting assignable causes of variation. This technique of control chart was developed by Dr. Walter A. Shevards in 1924. Control charts consist of three lines. The one is a central line, the second one is a upper control limit, and the third one is a lower control limit. There are two types of control chart. One is a control chart for attributes. The second one is a control chart for variables. For attribute charts are those charts which cannot be measured numerically. So these are the qualitative characteristics which can not be measured numerically. Whereas the variable chart, see this is a variable chart, and for variable charts, what is meant by variable? So variable is a quantitative characteristics which can be measured numerically. So that means those characteristics which can be measured numerically is called as a variable. For example, length, diameter, weight. So all these are a quantitative characteristics and which we can measure. So that means weight can be measured in kg, gram, so etc. So all these variates we may be interested in controlling the mean and range of the variations. So therefore in control chart for variables there are two types of control charts. So one is a control chart for mean and the second one is a control chart for variable, and these charts are useful in detecting assignable causes of variation. So that means we can use range chart when normally the range chart is related with machine setting, whereas the average chart is related with machine setting, whereas this range chart is related with the negligence on the part of operator. Suppose if there is a deviate in machine setting, so that can be detected through the mean chart, and the negligence on the part of operator can be identified through the range chart. So in this control chart for variable and particularly for mean chart, so first we have to find out the center line, then the upper control limit and the normal and the lower control limit. Suppose if you take x as a quality characteristic of interest which follows normal which follows normality. So that is, if you take x as a normal with mean mu and variance sigma square, we know that x bar follows normal with mean mu and sigma square upon n. So this means the expected value of x bar is mu and the standard error of x bar is sigma upon root n. Suppose if the standards are known to us, so that means if we know the value of mean mu and variance sigma square, then we can use the formula to get the value of these put the values of this mean mu and variance sigma square, and we will be getting three limits. The one is a central line, so that means if expectation of x bar bar is equal to mu, so take the value of mu as it is and plot this as a central line. The upper control limit should be taken as this mu plus sigma upon root n, and the lower control limit should be taken as mu minus sigma upon root n. So that means suppose if we are interested in 3 sigma control limits, just we have to multiply this value by 3. When mu is unknown, so for example if the value of mu is unknown, then we need to estimate x bar bar. So that means first we have to collect the data. From the data we need to find out the value of mean, and once we find out the mean of all the samples, So we are getting mean of the first sample, mean of the second sample, mean of the nth sample. Suppose there are n samples, then we need to find out x bar bar. So x bar bar is nothing but my overall mean of all the samples, and this x bar bar is used, and we know that this expectation of x bar bar is equal to mu. So x bar bar is an unbiased estimator of mu. So therefore sample mean should be taken as x bar bar, and which can be calculated by using summation x bar I divided by k, whereas k is nothing but my number of samples. And also the sampling distribution of range can be calculated by using expectation of r is nothing but my d2 sigma, where d2 is a constant depending on the sample size. And we know that expectation of r is equal to r bar. So r bar is equal to d2 into sigma. So this implies sigma is equal to r bar upon d2. And standard error of r is nothing but d3 multiplied by sigma. And what is this r bar? So r bar is nothing but the sample range. So that means if we have the data of k samples, so the number of samples are k. So how to calculate the value of range? So suppose for first sample, identify which value is the minimum value and the maximum value, and take the difference between these two observations. So we know that range is equal to largest value divided minus smallest value. So likewise calculate all the range values and then take the overall mean of the ranges, and that can be calculated by r bar is equal to summation ri upon k. Now set up the control limits, and Shepard has given the control limits by using the 3 sigma control limits for x bar chart, and this can be calculated by using the formula. And what is that formula? The formula is expectation of x bar. See, this is the formula, just I am highlighting this formula. So expectation of x bar plus or minus 3 standard error of x bar, and this can be calculated by using, so we know that expectation of x bar is equal to x bar bar, and the standard error of x bar is equal to 3 sigma upon root n. So put the values, so that will gives us, just I am highlighting this. See, this is the highlighted portion. So x bar bar plus or minus 3 sigma upon root n. So this implies x bar bar plus or minus 3. Suppose if the standard deviation is unknown, both the parameters are unknown, then we need to put the value of mu as x bar bar and sigma as r bar upon d2. And that will gives us the value x bar bar plus or minus 3 upon d2 root n into r bar, and that is the value x bar bar plus a2 r bar. And what is my a2? The value of a2 is 3 divided by d2 into root n. So therefore my central limit, my central line is, what is my central line? So the central line is this value. So the central line is equal to x bar bar, and what is my upper control limit? For upper control limit we take the value as plus x bar bar plus a2 r bar, and for lower control limit the value is x bar bar minus a2 r bar. So these are the 3 limits. The first limit is x bar bar. The second limit is, what is my second limit? The second limit is nothing but upper control limit, and the upper control limit is x bar bar plus a2 r bar, whereas the lower control limit is x bar bar minus a2 r bar. So for upper control limit, take the plus values, add those values a2 r bar, and for lower control limit we need to subtract a2 r bar. So that will gives us the central line, upper control limit and lower control limit. Since the value of d2 is a constant depending on n, a2 also depends only on n. See, what is the value of a2? So a2 is nothing but 3 divided by, see, this is the value of a2, just I am highlighting this, the value of a2. So the a2 is nothing but, see, this value 3 divided by d2 into root n. So since the value of a2 depends upon n, the value of A2 depends upon n, and the value can be computed and tabulated for different values of n from 2 to 20. So therefore, for control charts for variables, so when the standards are known, suppose the values of mu and sigma are known, then just we have to put the value in our 3 sigma control limits, and whenever the standards are unknown, so that means we need to find out their estimated value, and we know x bar bar is used to estimate the value of mu, and sigma can be calculated through the value of range. So mu can be calculated through x bar bar and the sigma can be calculated through r. So what is my sigma? So sigma is nothing but sigma is equal to r bar upon d2. So find out these values x bar and put those values in the formula expectation of x bar plus or minus 3 standard error of x bar and get the values of control limits. So these are the control limits for mean chart. We will discuss control limits for R chart in the next lecture. Thank you very much.